So, you want to be a DevOps engineer? Welcome. In this video, I'm going to share with you my personal experience as to how I moved from a Linux engineer to a DevOps engineer. My name is Ahmed. I am a senior cloud and DevOps engineer, and I'm happy to share this video with you. So, let's start by defining what DevOps is, or in more technical terms, what it isn't. So, DevOps started as a movement and a culture to make sure that all the stakeholders of an application or a project are in the same room. So instead of having developers in a room, having their own targets, having their own plans, having their own KPIs, QAs in another room with another set of goals and targets, operations are in a third room, perhaps in a different building, and they too have their own strategy and how they want to spend the next quarter. So the term DevOps was coined to ensure that everybody shares the same goals, shares the same project, and all of them work in that project at the same time with the same set of tools. However, over the years, it was hard to let operators write code and debug applications while still maintaining their job description. Similarly, you cannot let developers go and understand how the Linux kernel works and how the network switches can be configured and how to find the root cause of why the server got restarted at 2 a.m. after midnight. So companies started to hire people with enough background to handle this role, which is to ensure that code travels from the developer's machine, the developer's laptop, all the way to the production environment, to the production server, and also have enough feedback from production so that bugs can be solved and features can be added in the least possible time and with the most efficient ways. Hence, we have the term a pipeline. So those staff that companies hired with that mindset were called DevOps engineers because they apply what a DevOps culture should be. So with that, DevOps transferred from a movement to a job description with juniors and seniors and team leaders and supervisors and whole units serving that purpose. So now that we know how DevOps evolved to the way it is now, let's see how can you become one. So as I mentioned, DevOps contains two words, dev and ops. So let's start with the dev part. The dev part is when code starts being written on the developer's laptop. So in order to be a successful DevOps engineer, you must have some programming background. If you are coming from Linux, like myself, it's not that hard to learn a programming language. And I'm not asking you to become a full stack developer or a back-end developer or somebody who knows how to write assembly. I'm just asking that you have some solid background about a programming language of your choice. There are many programming languages today, and all of them are fairly easy to start learning. There's never been much easier way for you to learn a new programming language. And if you are asking about my personal opinion as to which language you should start with, I would blindly say Python. That's because Python fills the tiny gap between being a scripting language that can be used on a shell to like rename a bunch of files or move data from one database to the other, or perhaps quickly create a CSV file out of some data, and being a fully fledged object-oriented programming language that can be used to build large applications with complex business logic and APIs and even graphical user applications. So Python would be my choice if you are asking me. What about Go? Okay, so I received many questions about whether a DevOps engineer should learn Go to become a successful DevOps engineer, and the answer is definitely no. It's true that there are many tools today that are used in DevOps written in Go, like Kubernetes, Docker, Terraform, Prometheus, and others, but unless you want to contribute to those projects, unless you want to write code and help those projects grow, which is of course a good thing, you don't need to learn Go to be a DevOps engineer. You just need to learn the basics of programming and applying that to one of the available programming languages. If you don't like Python, you can pick another language like C# or PHP or JavaScript or Java. It's your choice, but you need to have some programming background. Then once code is written, it needs to be stored somewhere, and that somewhere happens to be the version control system. And the obvious choice that I'm going to give you here is Git. This is not to say that there are not other version control systems in the market. There are, like Subversion, for example, but the most well-known and popular version control system used today is Git. And that's why you have to learn Git, and you have to be somewhat proficient with Git. So the skill level of this specific tool is higher than programming. So you need to know your way around Git, you need to know your way around branches, commits, push, pull, rebase, revert, and so on. And if you want to really stand out from the crowd, after you learn Git, you need to learn a branching strategy, and I'd strongly suggest you learn Git flow. Learning Git flow will make you not only understand how Git works, but also how to understand how code gets professionally written and versioned, and how you can move from one version to another, and how to roll back quickly from a failure, and how to trace the cause of some error that happened, or some fault, or some bug that appeared. Now, once code has been written and stored under version control, it needs to be built and tested. Many people think that building is only specific to compile languages. So, for example, they say, okay, we have a C++ application, we need to compile it, this means we need to build it. Or we have a Java application, we have a Go application, we need to build them, we need to have the binary files, and this is the product of a build process. And actually, this is not entirely true, because building is putting the code, whatever that code was, whatever programming language that code was written in a shape that is ready for being deployed. So indeed, if you are using a compiled language like Go, for example, building will definitely involve compiling the code into an artifact, into a binary file. Because Go cannot run by itself on a server, it needs to be compiled into a binary file, and that binary file is the executable that will run the application. But there are other languages that are not compiled by nature, like Python and PHP and JavaScript. Those languages, again, will be built but not compiled. So the compile step will not be part of your build process, but you'll still need to build the application. At the least, you will need to zip the files that are needed for this application to work in a compressed file, like a tar file or a zip file. And this is your artifact. This is the file that will be deployed to the server, and this file is responsible for running the application. In some languages like JavaScript, it's not only zipping the file, but it also involves downloading prerequisites, like for example running npm install and getting all the packages from the package to JSON file and adding them to node modules and so on and so forth. So my point here is that building does not necessarily mean that you need to compile the language, and that if you are not using a compiled language, there is no need for a build step. This is totally false. You need to build your code even if it was a bash script. Once the code is built, the artifact needs to be stored somewhere. And an artifact here refers to the file that is the product of the build process, whether that file was a binary file of a compiled language, or as we said, a zip file or a compressed file of a non-compiled language. This file needs to be stored somewhere. And luckily, most of the build servers, I'm going to talk about build servers in a moment, most of those servers, they have their own features of storing artifacts. If not, you can use a third-party artifact like Nexus or JFrog. Next, we have testing. So now you have built your application, you need to test it. Some tests are run during the build process. So for example, in Go or in C++, if the code has errors, it will just not compile. So an error will quickly be flagged and the build process will fail. And here developers must be notified as quickly as possible that the build failed and that they must go and fix whatever error there was in the code so it builds successfully. However, in some other languages, like as we said, JavaScript or PHP or Python, since there are no builds, so we're just gonna run the tests on the files themselves. When it comes to testing, there are a lot of tests, really lots of tests, starting from linting the code to ensure that it just abides to the format that you want or the coding standards. You have smoke tests, you have integration tests, you have end-to-end tests, you have component tests, and so on and so forth. Testing is a large topic, and it's definitely not part of a DevOps engineer job description. But again, you need to understand how QA works. You need to understand how the quality assurance personnel do their work. As a bonus, you should also learn a testing framework, like for example, Selenium. It will greatly enhance your ability to understand how QA tests are run, and also it will give you greater visibility into how to incorporate that framework in your build server and in your pipeline. Once building and testing is complete, you need to move to the second step, which is putting that code on an environment, regardless of that environment, whether it was a testing environment or a staging environment or a pre-production environment or a production environment, but just deploying it somewhere is your next step. And this is where the ops part of DevOps starts. So now you need to prepare a platform for your application to run. And by platform, I mean the whole stack, including the hardware, the software, the operating system, the machine itself that will host your application. So here we're going to start the ops part of the DevOps engineer. And when it comes to the platform, you have obviously two choices. Either you're going to deploy on-prem, which means that you will have your own hardware, your own network switches, hardware servers, wires, racks, air conditioning, and everything. And of course, this will be managed by a data center team. You'll not be tasked with managing this. Or you are going to use a cloud provider to host the application on their own hardware. And of course, this choice is purely depending on which company you're going to be working for. But I can assure you that most of the companies today are moving to cloud computing. And those that are not moving right now, either they are planning to make that move somewhere in the future, or they are restricted by governmental or security rules that prevents them from going anywhere near the cloud, like for example banks. So if you want to invest some time, I would strongly suggest that you start learning about one of the three cloud provider giants: AWS, Microsoft Azure, and Google Cloud. You'll need to have working background about the cloud provider of your choice, and you'll need to know the different tool sets that they provide. If you're asking about my personal opinion, I'd definitely say start with AWS because it is the one with the largest market share, and it is also the most well-known of all the three of them. If you like certification and you think that it is the guaranteed way to sit and study and memorize things and try them out, then I'd suggest that you go and study for the AWS Certified Solution Architect Associate. It's a fairly easy and entry-level certificate, and it will give you an immense level of knowledge about AWS and all or mostly all of its tools. After studying for this certificate, you will be in a much better place knowing about AWS products than before. Then once you chose whether you are gonna go for cloud providers or you're gonna deploy on-prem, you need to move to the next layer in the stack, which is the operating system of choice. Again, the choice will largely depend on the company and the project and what exactly does the application wants from the operating system. But I would blindly say that most of the applications today are running on Linux. At least if you have limited time and you want to invest in learning about an operating system, I would strongly suggest that that thing would be Linux. If you have more time, it never hurts to learn more about Windows. Microsoft has taken very serious steps in the last years to move its operating system to a robust and mission-critical one. However, my personal opinion is to start with Linux. And when you want to choose a flavor, again, I would strongly suggest that you start with Ubuntu and Red Hat. If you have more time, you can learn more about other flavors of Linux like Arch Linux and others. So now you learn about the cloud provider or the on-prem environment that you're going to deploy your operating system on, and you learn about the OS itself, whether it was Linux or Windows, Ubuntu or Red Hat. Now comes the next step, and this next step is optional. So you either go for it or you don't go for it, depending again on the requirements of the company that you're going to work for. So you're either going to use containers or you're going to deploy the application on the virtual machine itself, on the bare metal. Again, most of the companies today are taking the container way, and they are moving heavily towards Docker and containerization. The reason, of course, is obvious because containers have lots of cost saving. They are robust, lightweight, they can be easily moved from one instance to the other. But that's not, of course, to say that containers are the silver bullet that are going to solve all the problems. In many cases, they might not be the best choice. However, again, if you have time, I would strongly suggest that you study containers and Docker. And if we talk about containers, we definitely should talk about Kubernetes, the giant de facto container orchestration system alive today in the market. It is developed by Google, and it's taken the world by force since its first inception in 2014. Kubernetes is increasing in its popularity, and it will definitely add a lot to your skill set if you study it. Now you have the dev and the ops parts ready. Now you need to move code from dev to ops. This is called deployment. And actually this pipeline that we are talking about is very much well known as CI/CD, which stands for Continuous Integration, Continuous Deployment Pipeline. And the reason will be clear in a moment when I finish describing the pipeline as a whole. So now you need to deploy the code from the Artifactory to your environment servers. But before you do that, you will need the very last step before deployment, which is preparing the environment, whether it was using containers or it was using pure virtual machines, for the application deployment. Nearly all applications have some requirements. So let's say they need some kernel parameters to be set, they need some users to be created, they need some configuration files to be added, they need some parameters to be tweaked here or there. This is the role of the configuration management tool, and this is the last part of the ops stack right before deployment. Configuration management ensures that your infrastructure, or your servers to be precise, are always in a good shape. And by good shape, I mean they are always ready to host and run the application in the most efficient manner. This means that if one of the parameters or one of the configuration settings on the server changes for some reason, the configuration management tool is responsible for getting those settings back to the way they were. And they do that blindly. So you just run the tool and it just configures the server back to the way it was. They're very brilliant at that. We have three of the most well-known tools in the configuration management world, in no specific order: Ansible, Puppet, and Chef. If you've never worked with configuration management before, I would strongly suggest that you start with Ansible, as it is the easiest one of them. But that doesn't mean, again, that it is the only solution for all your configuration management tools. But again, it is easy and it will give you an overall view of how configuration management tools work and why you need them. Once you are proficient with Ansible, I strongly suggest that you pick one of the two slightly more advanced tools, Puppet or Chef. Once you have all that in place, now comes the deployment step. The deployment is very easy. It could be just uploading files from the Artifactory or from the version control system to the environment servers. Or it can be slightly more advanced, especially if you are using Kubernetes as your orchestration system, because Kubernetes has lots of files and it needs a special way of deployment. So if you're using Kubernetes, I strongly suggest that you invest time learning about Helm. Helm is a very well-known deployment tool. It's called the Kubernetes Package Manager. It will make your life a lot easier if you are using Kubernetes in your environment, and it will very easily integrate with your build server. And speaking of build servers, let me give a quick description of what a build server does and why you need to be proficient in one of them. A build server is the orchestrator of this entire pipeline, of your CI/CD pipeline, from code in the version control system all the way till it is on the machine, even if that was a container. So we have many build tools in the market. So for example, we have Jenkins, which is one of the oldest tools. We also have Circle CI, Travis CI, Bamboo, Drone, to name a few. We also have build servers or build pipelines that are built in or integrated with the version control systems. So for example, GitHub has GitHub Actions, Bitbucket has Bitbucket pipelines, and both of them can handle a pipeline the same as Jenkins or Bamboo or any of the standalone build servers on the market. Also, GitLab has its own GitLab CI, which does the same job. Cloud providers as well, each one of them has some sort of a build tool or a build server there. So let's say, for example, AWS, they have a tool called Code Build that orchestrates and controls your pipeline. So build server obviously is one of your most important tools to be in your skill set. You need to pick at least 2 build servers and be proficient in. Maybe you can start with Jenkins and then move to Bamboo, or like if you want to fully embrace the cloud provider, you can learn the Code Build of AWS, or if you're using Azure or Google, you can use their own tools for that. But you definitely need to have at least 2 build servers under your belt. So deployment is going to be run through the build server, and whether you're using Helm or any other tool for deployment, just uploading the files, as we said, uploading the artifacts from the Artifactory to the server and restarting the application so that it picks up the new version, you will need to use the build server for that, and Helm seamlessly integrates with any of the build servers out there. It's just a binary that you download, and it can be very easily used with deployment. Now, the final step that we have to close the pipeline is the feedback cycle. So now the application is running. It passed all the tests and it moved from one environment to the other all the way till we're all confident that it is a good candidate for being deployed in production, and it was deployed in production. Clients started using it, everything is fine. But you need to keep an eye on that application. You need to be aware of whatever happens, aware of features that needed to be added, bugs that needs immediate attention or that needs to be fixed in the next release. So for that, you need to monitor your application and to collect its logs. So for monitoring, you have metrics. So the application, as all other parts of your infrastructure expose metrics. And metrics are just numbers that describe how your application is running. For example, if the CPU is high, like on 90% for some 5 minutes, this is an important metric to pay attention to. You need to know why the CPU has spiked to 90% if its normal ranges is 60 or 70. If a function in your application failed, this is another metric that can be exposed, that this following function has failed while executing XYZ action. That is another metric. And when it comes to those metrics and this way of monitoring, you need to use a tool like Prometheus, which is an open source tool, and it's very easy to understand and learn. It can also be very easily integrated with another tool that is called Grafana, that is used to build nice dashboards, and it can give you a full picture of what exactly is happening on the application, on the infrastructure, and in the code itself. The next part of the picture is logs. So if you have an application that consists of multiple components, which is referred to sometimes as the microservices architecture, then probably each of those components is having a stream of logs. You need to collect all those logs in a central location, which is sometimes referred to as log aggregation. You need to have a central place where you can view all those logs. You can correlate different events when they happened. So let's say, for example, you can trace something that happened with the same timestamp in other logs and see exactly what has happened in other components that may lead to that failure to happen. When it comes to log aggregation, I suggest you learn the Elasticsearch and its ELK and EFK stack. So the ELK stack is just a fancy name for Elasticsearch plus Logstash plus Kibana. And the EFK stack stands for Elasticsearch, Fluentbit, and again, Kibana. Kibana here is the tool that you use to visualize Elasticsearch logs, to run complex queries against those logs, and to correlate different log sources together and see a full picture of what happened log-wise. Logstash and Fluentbit are just log shippers. They are tools that are used to collect logs from different sources and then ship them to Elasticsearch. So now that you have the logs and the metrics in place, you need a way to communicate them to the developers and to you and to the other stakeholders in the project. This is the role of messaging systems. And of course, when it comes to messaging systems, again, I will recommend Slack because it is the most well-known messaging system out there. Not to say that there are not other tools, there are other tools, but this is just the most widely used one. And Slack excels in a point, which is that it exposes webhooks so that you can easily integrate that webhook with virtually all other applications. So for example, you can hook up Prometheus with Slack and you receive real-time alerts on a channel. You can change the icon per alert so that you can have alerts with a specific icon so that they are high alerts that you need immediate attention, or they are like medium alerts that do not need immediate attention, and low-level alerts with like low attention. Also, it can be integrated with Elasticsearch so that, for example, you can also monitor your logs for specific log lines. When they appear, you need to be notified. So it has lots of possible integrations through the webhooks. So now you have a complete pipeline starting from code being written on the developer's machine all the way to production, and again, all the way back to the developer machine, which is referred to, as I said, as CI/CD pipeline. So those were the steps and the skills that are needed by a DevOps engineer. If you're thinking about switching your career to DevOps, or if you're a fresh graduate and you think of pursuing that career, this is what I think are the tools and the steps. So I hope that video was of use to you. And if you have any questions, please post a comment below. I will leave links in the description for the tools that I've talked about and to some tutorials and articles that I think they are useful. Thank you for watching this video. If you liked it, please press the like button and make sure you subscribe to my channel to be notified of new videos as soon as they arrive. My name is Ahmed. Thank you for watching.